So my Bio 2 students went over to the room next door, so I can take my mask off here so I can lecture with you guys. Welcome, 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 troops. Hope all is going well here on this Friday. I don't know if I've gotten some of your timeline projects already. Hopefully that's going well. It's not a difficult one, so I think it's due by midnight tonight. Is that right? Anybody? Yeah. So for those that maybe haven't finished it or whatever, make sure, do diligently, like today when I'm done with you, you can maybe finish that up. Also, if you want to bring it up, if you want to, let's put it this way, as long as you submit it on time, and then if you don't get up here today, but then bring it by with me in a hard copy, that's fine too as well. I know it's done, but it's easier to grade if I see it in person, but obviously you can take a video and that, and I can grade it that way too as well. Biggest thing is make sure that you're finished it by midnight tonight and make sure it's where it needs to be, okay? Real quick, Wayne, did you get that reading guide that I resent you? Is that what you were looking for?
Yeah.
Okay, perfect. All right, I just remember to do that because I did that yesterday. I was making sure that you got that. Okay, so what I'm going to do today is I'm just going to go through, hi Piper, I'm going to go through section 2 of the periodic table, okay? And then got a couple things that I'll put you guys in motion to do as we start using the periodic table. And next time when I talk to you on Tuesday, I'll bring my periodic table, or I'll move I might tape it before to where I'm standing in front of that big periodic table, I got on the other side of my room, so I can point and do some references to that, which goes in line with the little assignment you guys will be doing between now and next week too, a little coloring, little activity here that I'll go over after I go through section 4.2, okay? So I'm gonna go ahead and turn off so you see this better. Likewise, even though this is the same slides that you have at the top of Unit 3, okay? All right, so should be able to see that okay. If not, I'm making a video copy of it too. If you missed out or so on. So, okay, so the periodic table is so important for us just simply because it tells us so many things about elements, natural occurring elements. And remember, everything that's on a periodic table is natural, all right? They all follow certain properties. So they just didn't put them in this arrangement just for the heck of it. There's actually reasons why, and the assignment that I will go over that you'll kind of begin on, that kind of stems over a little bit into section 2, but more into section 3, all right, is the tail end of this. But before I really jump into why things are where they are on the periodic table, I want to explain a couple how you figure things like atomic number and mass and stuff like that, because we haven't had really a chance to talk about that, okay? All right, so obviously from organizing the periodic table, and this goes in line with your 4.2 and your outline if you're filled out. Remember I told you the outline I gave you, you don't have to turn that in or nothing, but it just helps you stay organized, okay? You have this PowerPoint, whether you're watching it here, watching it later, or doing it on your own, okay? You have this in multiple forms, so I'd rather give you more versions of this with me talking or by yourself. That way we're all on the same page, okay? So basically the periodic table is groups of similar elements, like I said, okay? And they're set up what they call by periodic law. And remember, when they talk about laws in science, they tell you something specific. Remember, we talked about that first semester, that first few weeks in that first chapter about when we hypothesize and we theorize, but once we finally get something tested to the point where it tells us something every time. So when you hear the term law in science, remember it's saying, we know this is going to happen, okay? So by periodic law, okay, elements are listed in order for protons, which is the positive charge element, or excuse me, positively charged particle found in the nucleus, okay? And by law states that when elements are arranged this way, they have similarities in their properties, okay? They have things in common, okay? So that's an important. So by periodic law, that's why they're arranged how they start the way they do, okay? All right, so a couple things you hear me a lot. The term periods refers to horizontal, okay? So when we talk about the periods, or like period 1, 2, 3, 4, we're talking about up and down, okay? Oh, I'm sorry, up and down. She's sorry. Is this Monday or is this Friday? Horizontal. Duh. Periods go left to right. Okay. Sorry about that. Okay, let's start back over that. So horizontal rows in the periodic table, ones that go across the x-axis are periods, just as the number of protons and atoms. So basically, as you go from left to right, you know that the atomic number and the protons, because they're directly related, is getting larger. So that's how they're arranged, from left to right, and then it comes back to the second row, and you go all the way across, and it goes back to the third row. So as I'm going left to right, top to bottom, I'm getting larger in number, therefore I'm also increasing in protons within the nucleus, okay? All right, but groups are the vertical ones, okay? So these are the ones that, in my opinion, and when I had you guys write that on your periodic table, or more so not necessarily today, but the next time, I'll really talk about the importance of that +1, +2, +3, -3. You know, it makes sense. At the top of these groups, or the vertical columns, they have to do with the charge, okay, that's associated, or, here's an old word for you, valence electrons, those extra electrons they have in that outermost shell. And that is the key to chemistry about what attracts what or what repels. As we know, pluses and minuses, opposites attract. And the polarity, or that, is really what really is the key element with chemistry, okay? So we'll really dabble into that as far as the charges, okay, as we get a little deeper in this too as well, all right? So a group is a vertical column elements in the periodic table, and one of the things they have similarities, like I said, the same number of valence. Remember, the term valence is those extra electrons that spill over into the next energy level. I.e. example, let's say we're all in one of those, we're in a Tahoe, and you got me driving, you got a passenger seat, you got the seat behind, and let's say this particular Tahoe is the extended one, we have 3 seats behind us. So you got the passenger, driver, and then you got 3 rows. And comfortably, 1 driver, 1 passenger. Okay, but I got 7 of you. All right, so the next 3 of you pile into the next seat. So 3 of you pile into the row right behind me. That's 5 total. So then you got 2 more rows, and the last 2 you got to climb all the way in the back. So 2 of you are in the back seat, but you got plenty of room. You'd be considered like valence electron. We can still fit more electrons in there if we need be, or more people. So let's think it like that. So just like when you load so much into something, all right, when you can't get any more in it, it has to go to the next energy level. So remember, valence electrons are those extra electrons that stem over into the next energy level. And that is what is going to create that ion, that positive negative charge that you get associated, which then also causes kind of like how magnets attract and repel each other. Okay? So we'll talk a lot about that during chapter 4. Okay? So, and they also will have similar properties, which has to do a little bit with the naming stuff as well. All right? Okay. So, the keyword ions. Okay? So, when we're talking about elements, that's one thing. But when we start talking about the word ions, I-O-N-S, okay, we are starting to talk about something that is charged. What do you mean by charged? Has a plus or a negative value, or a plus or a negative charge. So it says right here, an ion is an atom, which we find on the periodic table, or a group of atoms that has lost or gained an electron. So because of the lost or gained electron, it turns it into having more pluses or more negatives, therefore it gives it a charge, positive or negative. So we call that an ion, or ionization taking place, okay? So for example, lithium atom loses 1 electron to form a +1. So here's the key thing. Notice it says a +1. So you're like, well, Meyer, if it has a -1 charge, or a +1 charge, okay, in this case, but it lost an electron, why is that? Okay, it's kind of the opposite rule. So if I lose an electron, this is telling me I need 1. So it has a +1 charge. If I had a +2 charge, that means I lost 2 electrons, okay? Or things of that nature. So it's the opposite. So if it's a plus charge, they got rid of. So it lost an electron to stabilize it. All right, it went somewhere else. Right? If it's a +3, that means it lost 3 electrons. So plus charge is representation of what they lost. So then take the opposite. A negative charge is an example of what they need to fill up that outer row. Okay, so that's where you get that positive, negative, and you think a lot of times plus would be I have an extra one. No, plus charges means I lost. Negative charges mean I need. Okay? All right, so this is just showing a little diagram of lithium, which is in the first column, because it's a +1, and it's just showing you how lost one went from an atom to an ion. Okay? So a fluorine atom gains 1 electron to form a 1 charge. Okay? All right. So in this particular case, fluorine would then be, if you looked on the other side of the periodic table, which I'll talk about, fluorine is an example of having gains an electron, so that means it has a negative charge, meaning it needs 1 more electron to fill its outer shell. Because once those outer shells of the element are filled, they're happy. It's like having an entire pizza to yourself and eating it. I'm full, I'm happy, I'm just going to sit here. I'm not going to be hangry anymore. All right? or anything. All right? So that's what they call being a stable atom. And I'll give you some examples here of that here in a second. Okay? All right, so here's a little bit of basic math that's very easy that paying real close attention to. Okay, so like in algebra, how you solve for x, okay? The atomic number, which is the element's number, 7, 12, whatever, they call it the capital Z. I don't know why, but they gave it a symbol. So starting to recognize when they ask about the Z value of an atom, they're talking about its atomic number. So the Z is equal to the number of protons. So, i.e. example, if element number 17, we know because the number 17 represents how many protons, its Z would be 17. Okay? So this number of the element is also the number of protons or positive charged particles they have in their nucleus. Okay? Positive charged particles in the nucleus. The A is what they call the mass number. So you're adding two things. You're adding the protons and the neutrons. The neutrons meaning neutral charge, no charge at all. Remember, the neutrons are in the nucleus with the protons. Okay? So if I want to find out the atomic mass, I add protons and protons and neutrons. That number gives me the overall mass or the size of the nucleus. Okay? So we call that the capital A. Okay? Capital A of it as well. All right? So if I was looking at this, and it's a little color diagram, obviously I am, the mass number A of the number of positive, okay? So, for example here, if the Z, and it's pointing to red, Z is representation of protons, I could count them and go 1, 2, 3, 4, 5. So if I wanted to know what element this was, I could just look at the periodic table. Where's my periodic table? It's floating around here. And if I wanted to, just for examples, I don't have to, that element number 5 on this is boron. Okay? So this is an example of a nucleus of boron, which is element number 5 right here. It's because I know that because there's 5 protons, 5 positive charges, and the protons present is equal to the number of the atomic number. So then if I wanted to know the actual atomic mass, I would add up all the colors. Blue is representation of the neutrons. So I got 1, 2, 3, 4, 5. So I have 5 blues and 1, 2, 3, 4, 5 reds. So my atomic mass should be 10. So if I look at this right here, okay, and I look at my atomic mass or whatever, you should see something around below the letter B on your periodic table that would say something like the value of 10. Okay? So that number, and I'll show you in a second on another slide, that tells you how that works. All right? So the A of an element is protons plus neutrons, which are found in the nucleus. The Z is the number of protons, which is also the atomic number found on the periodic table. Okay?
I have a question.
Yes, ma'am.
So is there any ones that are like the same amount of neutrons and electrons, or are they all different?
Okay, so that's a great question. Protons and electrons are the same. Okay? So, for example, if I just randomly Torres, let's say 79 here. This is plutonium. Okay, it's a metal. So I know this number 79, which I'll get to. We know it has 79 protons, but it also has 79 electrons. That's something I haven't told you yet, though. But protons and electrons are equal because think about it. If a proton is a plus charge and an electron is a negative charge, and if I have this particular element 78, if I have 78 pluses and 78 negatives, what's my overall charge? Neutral, right? Plus, what's the line? Plus. So when it's just a regular atom, they don't carry that charge yet. It's when they become what they call that ion term, is when they start getting entry with when they lose an electron or gain electrons, then that throws the balance off, where all of a sudden now instead of maybe having 78 electrons, now I have 80 electrons. So if I have 80 electrons and only 78 protons, that's going to give me more electrons. So that's going to create an overall negative charge, right? And now we're dealing with the property chemistry is about pluses and negatives attracted. So I'll get to that, but that's the key thing. So when you hear the word ion, you have to think, okay, now we're talking about charges, plus or negative. And depending on what they are is how well they're attracted to each other, okay? Cool. All right, now we'll keep moving forward. This is just the basics, but I will cover that too as well. That's a good question. All right. So when I'm looking at the little periodic table that you have, like something like this or whatever, sometimes we don't know what this stuff means. So for example, I'm just going to break them and start real basic. So obviously the 0 is the symbol, okay? So this is oxygen. Usually standard, they write the name right underneath it. Above it here is 8, which is the atomic number, or the Z, which we know if that's an 8, it means it has 8 protons, okay? See this right here, 15.999, which is same as saying 16. So that's its atomic mass, protons plus neutrons. So like Torres asked, how do I know how many are there? Well, that's easy. If I want to know how many neutrons a average oxygen atom has, all I got to do is to take 8 and subtract it from 16. Because if there's 8 protons and I subtract it from protons plus neutrons, that leaves me 8 electrons. Does that make sense? Okay. If this atomic number was 17, 8 from 17 would obviously create an extra. I have 9 electrons. So you can add neutrons to the nucleus as much as you want, or as much as they can hold, but it doesn't change the element, because the only thing that's going to change this oxygen molecule to something different, change the protons. Change the protons, it changes the element, right? If I add 1, it goes to 9. Well, it's no longer oxygen. If it was number 9 on the periodic table, now it is fluorine. Okay? If I took it 1 away, went from 8 to 7, now it's nitrogen. But I can add neutrons because they don't have a charge, and all that does is make the nucleus bigger or heavier. Okay? Thus the term atomic mass. Does that help? Okay? All right. So, standard issue procedure, and like you said, yes, earlier, notice electrons and protons are always equal in a regular atom. Okay? All right, so no worries on that. All right. So here's what I was talking about, Torres, about isotopes and that plus or negative charge. Now is when we get into does the element or the ion or the isotope have a plus or negative charge? Okay? So, for example, the term isotope is an atom that has the same number of protons, because if you change the protons, remember you change the element, okay, as the other atoms of the same element, but they have more neutrons. So for example, hydrogen, okay, hydrogen right here, number 1 element in the periodic table, okay. Scientists know that they have 3 different isotopes, okay. So basically what this is saying is protium, deuterium, and tritium are names given to isotopes. It's still hydrogen, right? Because it has 1 proton. But what they've done is, with these particular hydrogen atoms, they have more neutrons, okay? So each one of these is a little different. So what it's showing you is, these are the 3 isotopes that hydrogen can create, meaning there's 3 different ways they can hold different numbers of neutrons, okay? So when you see, guys and gals, right, this average atomic number, the atomic number below that, what they're telling you is they know all the isotopes of that element. So it's like the laws of average. If I want to know what's the average of 3, 6, and 9, I'd add them up and divide by 3, right? Right, guys? Yeah, nod your heads. So that's the same thing. What they do is they add up the 3 atomic masses, protons plus neutrons here, protons plus neutrons here, protons plus neutrons here, add up those 3 numbers, divide by 3, and that gives you the average atomic mass is what you get off the periodic table, okay? Does that make sense a little bit? I know it's the first time hearing it, but we're going to talk ions and isotopes a lot, okay, because that's important, all right? Okay. So some isotopes, like I said, are common or others, are just certain ones, okay? All right, so how do the structures of atoms differ? So if you know the atomic number, which is the protons again, I keep saying that, but that's important to remember, and you know the mass number of the atom is protons plus neutrons in the nucleus, okay? So at this point, you can then calculate how many neutrons. Just subtract the Z from the A. Remember, Z is protons, A is protons plus neutrons, so just subtract the Z from the A will give you the neutrons in the nucleus, okay? So here's an example, uranium-235. Here's uranium. You see this number, 235. This is an isotope of uranium, okay? Anybody heard of Marvin the Martian before from Bugs Bunny? You know, the little guy with the Roman helmet always wants to blow up Bugs Bunny and Earth? And he talks like this. He always blows up the Earth with uranium-238. 238 is an isotope of uranium. Uranium is what gives us nuclear power, okay? So what they're saying is this particular isotope of uranium, we want to know, obviously, what or how many neutrons are in that uranium, right? So here's what you do. If this is the atomic mass, guys and gals, and we know that on the periodic table, the legal cheat sheet we have, that clear down here, element 92, wherever 92 is, uranium, there it is, uranium is 92. So that means 92 of this 235 are protons. Everybody follow me? So I'm going to take 92, which is the A, and subtract from 235. And that's going to give me a number, right? So when that number is determined, that tells me how many neutrons that uranium-235 has. So let me do that math here for you. Okay? So there's what I just said. Atomic number is the Z, so subtract it from A. So what this is saying is uranium-235 has 143 neutrons in its nucleus. Okay? If this was uranium-238, which there is a uranium-238 isotope, I would take 238 minus 92, and then that would give me a different neutrons. But the bottom line is this is uranium because it has 92 protons. If this proton number changed, I would not have uranium anymore. Okay? The neutrons can vary. Okay? The more neutrons, the bigger the nucleus. Okay? So, finding the neutrons, just take A minus Z, or protons minus the atomic mass will give you how many neutrons are there. Okay? So far, so good, you guys? Okay? Okay, she's nodding her head. It's good. All right, so here's another little breakdown. So here's what you would see on your periodic table. Sometimes when you see them on a worksheet or listed in a problem or something like that. All right? So first things first, we need to cipher out what all these mean, where they're at. So obviously we know the Cl is the element symbol. So I know this. This is chlorine. Okay? All right? Up here is the upper left, this red one, upper left corner, that tells you that if you had to write this in a problem, the proper way, it's kind of like when you capitalize or punctuate, there are kind of some rules to when you're writing down the symbols for elements or isotopes, okay? So this is a good example. This is in your PowerPoint. I'm taping it, okay, and you'll see this. So what it's saying is, upper left corner, 37, this is the atomic mass of this chlorine isotope, all right? So this is the A. This is protons plus neutrons. The green, or lower left, is the atomic number. 17, so obviously, oh look, 17, so we know that. So that's the element on the periodic table. That's the Z. So the question was, all I want to know is, how many neutrons is in this isotope of chlorine-37? Well, just take 37 minus 17. So we know that this isotope of chlorine has 20 neutrons. I just subtracted 17 from 37, gives me 20. This one here is chlorine-35. It's another isotope of chlorine, okay? So I just, same thing, took 35, all right, minus 17, this has 18 neutrons. So even though they're the same element, the best way to describe it, this isotope is a little heavier than this isotope because it has a bigger atomic mass, because it has 2 more neutrons than this one. That's all, okay? So upper left is the atomic mass, that's the symbol, that's the atomic number, okay? All right? So how do the structure of atoms differ? Okay, so i.e. example, so we're talking the mass of a single atom. We're talking about one atom on this periodic table, okay, whether it's carbon or hydrogen or phosphorus, whatever, okay? So they wanted to know, how do you express one unit, right? So the atomic mass, or the abbreviation AMU, is equal to 1/12 the mass of carbon, right? Right? So basically what this is saying is the average atomic mass for an element is the weighted average of the masses of all elements. So this is confusing. All you need to know is atomic mass, or that number that I just showed you on your periodic table. If you look at the front of the book, it's located right here. Let me go back here real quick. Let's show it to you. Pop, 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 pop. Okay, this number right here is what they're talking about. This is the average atomic mass of this isotope. That's what's on your periodic table, okay? All right? So that's what it's telling you, okay? When you see that number is below that, all right? So the average atomic mass, when I say find your atomic mass, you just look at the periodic table. You will always have this periodic table in front of you. You can always use it. You don't have to memorize it. You just know how to read it, okay? All right. So, whoops, and that was section 2, yeah. So, not to overstep. So, section 3 is kind of what is now going to be dealing directly with the assignment that I put that you can start to dabble with that I'm going to put up here in a second, okay? All right, so all of you that are paying attention, and I'll rescan this. All right, so remember our workbooks I sent home with you, right? Okay, everybody nod your head that's got the camera on, okay? For this review, you're going to do page 15, okay? Which is directly with 4.2. You can write right in it and just take a picture of it. I will upload it here a second today for you, so you'll have a place to submit it, all right? So not a problem with that, so just be patient. But you can write right on it, take the pictures of the answer, okay? And then submit it that way. I will do that here when I'm done with you guys for the day for this block, all right? So, and I will say on your workbook, page 15. I'll go ahead and also scan this in case some of you, nobody has told me they've lost their workbook, but I'll go ahead and scan it so you can see it. But like I said, just write right on 4.2, page 15. You've already done the page 14 one. That's what you did, I believe it was the day before you left or the first day of class, and you submitted that one to me. So we're just doing the quick little concept review of what we just talked about, okay? Page 15, all right? And I'm going to put that in the Schoology here in a few minutes. Okay, so where we go from here. So what I'd like you to do, let me get back out of this. Go back into here, all right? Whoops, where'd I go? Okay. All right, so I'm back into my periodic table, chapter 4. Whoops. No. There it is. Okay, there we go. So, we're going to scan down here that says December 11th, troops that are watching. December 11th, periodic table coloring lab, ID elements in their group, okay? I'm going to put what I just showed you here, page 15. I'm going to put it right here in a second. Just be patient with me on that, okay? I forgot to upload that, but I knew you had the workbook, so I wasn't worried about it, okay? So here's what you're going to do, all right? Below are all the directions. I attached 3 copies of the blank periodic table for you that I want you to start down with. So as we're dealing and talking about this Tuesday and Thursday next week, I want you to start familiarizing yourself with section 3 and the actual parts of the periodic table. I'm going to open it in a second, but like what's an alkaline metal? What's a transition metal? Where are the halogens? Where are the noble gases? Where are the earth metals? That kind of stuff, okay? And it's very important to start familiarizing yourself with where everything is on this periodic table, okay? So I'm going to open it here real quick, all right? Open her up. You're going to see this assignment, all right? And it's going to walk you through. I'm going to blow it up a little bigger here, okay? So nice and bold there. So this is the little assignment, and I put on it all the way till next week because we're actually going to be working on this from class. This is 4.3 and 4.4, but I want to go ahead and get you started on it. If you need a hard copy of this between now and next Thursday, come up and get one, all right? Because it's a bunch of pages. I know Miss Torres is always up here. I see her because she's always up here because of ROTC, but if some of you need to come by and get it because of printer ink and all that, feel free, okay? I even have colored pencils if you need to borrow, all right? So this will walk you through the periodic tables, a list of known elements. This is what we already talked about, okay? So you'll read through this. I know, don't be allergic to reading. You can read, okay? All right? So it actually breaks down the groups. Group 1, alkaline metals. These metals are extremely reactive and are never found. You need to use your book, or you can look ahead into the PowerPoint, the little color-coded system, okay? But they tell you your groups, okay? So groups go which way, up or down? Periods go across, groups go up and down, right? So we're looking up these, we're talking vertical columns. So group 1 is actually this first, here's your group 1 right here. Group 1, there's a 1 right there. Group 2, and so on. So remember, groups are vertical, all right? So referring to that, let me get my arrow here. So I break it down and I actually tell you alkaline earth metals, they tell you a little bit about them, extra electrons. The groups they're located in are directly linked to their charge, which we're really gonna knock that out and master that, because that's really the key to understanding this. It's all about the charges. What can be attracted and stable to the other elements, okay? And that's what is neat about how this thing is organized, right? So this will list out all the groups, all the way group 13 and 14, and there they are, all right on the periodic table, okay? All right, we'll keep going down here. I had to scan multiple pages. So this is what's your student worksheet. This is what your coloring code. So I give you color. So you're going to then, on your blank periodic tables, all right, color the squares for hydrogen pink. Okay, so you will use a real thing to locate because your periodic tables, people, are all the way down here, are blank. Oh, and there's 3 of them attached in case you get too clustered and you get too busy with them. You can use more than one to color on for your assignment. Because I know if you're in class, that's what we'd be doing, and looking over your shoulder. I always had usually everybody like to have at least 2, maybe even 3, because when you start doing a lot more coloring and shading, all right, it gets really overlapping and gets confusing. So that's why I attached 3 blank ones to this. And if you come up, I've got it all stapled together where you can get it as well, okay? So I'm gonna go back up. So this is where those are at. So what you'll be doing, starting, you don't have to start it today. You just got that little thing here. Here's your directions. This is how you'll be coloring. So like for one, you'll color find hydrogen. You're gonna lightly color all the metals, and you'll be looking in your book and PowerPoint 4.3, all right, a little before that, okay, understanding that, okay, because I haven't really talked about it yet, which I haven't, but I want to, like I said, I need to start you a little bit of dabbling with it, all right, so it's not so foreign with you next week, all right. And you'll say draw horizontal lines. It tells you exactly what to do. All you got to do is follow directions. Those 12 different things you're going to do, either draw, color, or whatnot, or label on your periodic tables. So it could get pretty busy, so you don't need to put all 12 on one. If you're really neat with it, go right ahead, but you don't have to, okay? So when you're finished, you'll make a key that indicates which color. So make sure on the side, like you'd say, make your pink marker here equals hydrogen, yellow, all metal. So then you make a key on the side on your periodic table, so I know what all the colors and symbols mean, okay? Just like anything, I'm reading a map. Don't worry about this. I've added the blank copies. This was the hyperlinks that weren't working, so that's why I attached blank copies to the bottom of this. But this is the 86, the add copy bottom half, right? If you're a person that can do that, great, but I have empty copies, right? Then you have the little worksheet, the little questions. Well, vertical color, these are the little like reading guide questions that go with A, what I just talked about, and B, a little bit what you just did. So it's a recap of the instructional part about what exactly do the vertical columns represent? What do the horizontal columns represent? Okay, most of those periodic table are classified as what? All right, so and we'll go over all this next week. Okay, you don't have to have this done next week, but I'd like you to start it, if anything, at the conclusion of us talking about it on Tuesday in class. So you'll start dabbling with it. So if you just need today and Monday to get copies or kind of read through it, that's okay, right? But this is where we're going on this, starting today with continued on next week, all right? It's kind of like just a paper lab that we would do, okay? So here's all direct questions that go with it, okay? All right, and then you get to your 3 blank charts, all right? Okay, I'm gonna turn on the lights here real quick. So, we're back. So, just a simple recap. So, all right, still taping this, so for anybody that absolutely missed it, all right, looks like I got everybody in here, but if you had to rewatch it, because I realize, you might forget something, you can fast forward and so on, but not only we covered 4.2, we talked about the A and the Z, the atomic mass, the atomic number, what an isotope is, what an ion is, what are the charges and why. We're going to move further into. I don't want to overwhelm you with too much, okay? Then, in your workbook, which I'll upload it here in a second, but page 15 is a little concept review. You know how quick they go, right? There's page 15. You can write right in your book. I'll also print a copy and put it in there as an assignment, so you'll be able to upload it, okay? So don't worry about that. Just give me a few minutes when I'm done with you, okay? And then if you want to start dabbling with the coloring guide that I just went through, you can do that. But that's going to be our main focus on Tuesday, Thursday of next week, because this little lab thing, as you see, I put it all the way till midnight this time next week because I want to have plenty of time to walk you through and go through it before you ever have to submit it. Now, if some of you, if this is perfectly clear, this assignment, you can go ahead and work through it. I don't have a problem with that. But if you want to work at the same pace as what I'm working with you with it, that's perfectly fine too. That's why I extended it out for a week, okay? Okay, any questions so far? No? Okay, odd stuff. So if you want to get a hard copy, all you got to do is, I'm here in my room every day till 3 o'clock. That includes Wednesdays during study hall, right? Just knock on my window or come in through the office, come here. You can come and get a paper copy if you wanted the coloring guide stuff or whatever, okay? If you ever need to turn something in paper version to me, okay, you can bring it to me as well, all right? Because if there's a problem scanning, uploading, you know that, hey, I'll work with you on that. Just communicate with me, which you guys do a really good job, all right? And we'll make sure we get that taken care of, all right? So it's 11:07, you did awesome. You guys were fully intent for 38 minutes of hardcore. That's no different. If you were sitting in class, that's about how long the lecture would take, and then I would give you now time to work on stuff, okay? So that way, trying to utilize the time, so the remainder of the time with this, first priority would be finish this little concept review, okay? And then I'm gonna upload it here, so then give me a few minutes. And that's the only thing that's required of you for today by midnight to finish this, okay? You got plenty of time for this hour. And then if you wanted to start on this, that's great. But that's all we have for today, okay? So I see Noah, William, Audrey, and Torres faces there. And you guys have any questions? No? Feeling pretty good?
Mr. Meyer,
Yes,
did
sir.
you get my timeline?
When'd you give it to me, bud? Oh, did you?
I submitted it online.
Okay, I haven't had a chance to look, but I will look and make
Okay.
sure. If it's submitted, I'm sure it's there. You were going to do it on the computer, right?
Yeah.
Okay, now I haven't taken a look at it, but when I'm done with you guys here, I'll take a look at it, okay?
Alrighty.
Okay?
Thank you.
So, I'm going to shut off the video so it's not any longer than that real quick.